I have put both of our oak species together on the same page as a comparison. We've got Quercus rubra, red oak at the top, and Quercus alba, white oak at the bottom. Oaks are another ring porous species, and again we've got that large organized band of early wood pores and the much smaller, kind of compressed together, smaller vessels or pores in the late wood. What is significant to get you to the genus here is one, they are ring porous, but the other part is in the late wood we see this radial flame-like design, okay? And that is where these pores scatter into these smaller little designs, and if you look, even without your hand lens, when you cut into the transverse side and you look, you see it looks like little flames coming up. This is the radial flame-like design that they're referring to. Okay, the difference with what we're seeing here in red oak and white oak as far as the sample goes is that with white oak this was a much slower growing tree, so that you can see it's a much more narrow band of late wood. This will change with samples depending on the rate of growth, but look how small that late wood is. Okay, but even within that late wood you see these tiny little flames coming up that I'm highlighting here. Okay, so that's that flame-like design. How are we going to tell them apart? That gets us to genus. We've got rays, which I should mention, of variable width. There's a few examples here of rays being of variable width on both species. They are ring porous with that flame-like design. Now to separate the two from the transverse side is we look in the pores. And notice how these great big pores of red oak, look with your hand lens, you're going to see that for the most part these are hollow. But if you look in the pores of the early wood of white oak, they are filled. And notice the shine that you see in these pores. They kind of look like, I always say it looks like soap, looks like dish soap bubbles all through these pores. They're all really shiny. And this is called tylosis. Tylosis is a defense mechanism trees use to plug those cells so that disease or pathogens causing decay do not go up and down through that superhighway of vessel elements. Okay, white oak is famous for tylosis. Its heartwood will absolutely plug with tylosis, and only a narrow band of sapwood will contain hollow vessels for water to pour through. Okay, red oak, the vessels often will stay open even in the heartwood. It's not uncommon to, if you encounter tylosis, but that's usually around an injury where a tree has had an injury and it's filled with tylosis. Okay, white oak just completely fills everything with tylosis, making it really unique. Okay, so you'll get to oak from the transverse side pretty easily by looking at that it's ring porous, it has that cool flame-like design in the late wood, and then to separate the two, look for hollow pores in red oak and tylosis-filled pores in white oak. If we compare the tangential surface, I'm looking at the rays. Okay, remember we need to be making sure that we are on the tangential surface, which was that pattern on the board, the wavy pattern, right? So if that's my board, there we go, that's what I'm looking for. So make sure that you are looking at the tangential surface of your board, and then look for the rays, okay, the ray fleck. What I'm looking for on red oak are these little lines, looks like pencil lines. I'm drawing over the rays with my marker here. Okay, so that's what, oops, that was off. That's what you're looking for. On white oak, notice how much longer they are. Okay, so red oak has very short rays on the tangential surface. White oak has longer rays. So basically under 2.5 centimeters over here, and usually over 2.5 centimeters or 1 inch here. Okay, and that will help separate those two even without looking at the pores. On the transverse side, a quick glance on the tangential surface will reveal the two different species.